Back in 2012, the world of physics was just electric. We'd done it. We found the Higgs boson, the particle that gives everything mass. But it turns out, hidden inside that incredible discovery was a secret. A really unsettling one, actually, about the very fabric of our reality.
So the very data that gave us this huge win also led scientists to this absolutely terrifying question. Is our universe, stable? Or could everything we see, everything we are, just vanish in an instant?
Now, I know, that sounds like something straight out of a sci-fi movie, right? But this isn't just some wild theory. The actual numbers, the very measurements that proved the Higgs was real, were also the first big clue that our universe might be in this precarious temporary state. A state that, well, is pretty much doomed to end.
So to really wrap our heads around this, we've got to dive into what those Higgs measurements actually told us about the state of our cosmos.
Okay, so here's the key thing. When scientists took the measured mass of the Higgs and put it together with the mass of another particle, the top quark, the math pointed to something truly shocking. Our universe? It's not actually in its lowest possible energy state. It's not at rock bottom, so to speak.
And that brings us to this really mind-bending idea called the false vacuum. And believe me, it's the absolute key to understanding, well, both why we're here and why we might not be forever. The best way to think about it is with a simple picture. Imagine our entire universe is like a ball, and it's just sitting there in a little dip on the side of a massive hill. It seems stable, right? It's not going anywhere. That little dip, that's our false vacuum. But way down at the bottom of the hill, there's a much, much deeper valley, a state of way lower energy. That's the true vacuum. And if our cosmic ball just gets a tiny little nudge, it could roll right out of our dip and plunge all the way to the bottom.
And this isn't just an analogy. We have the evidence. Look at this diagram. It basically maps out the universe's stability based on two key numbers. You got the Higgs mass along the bottom and the top quark mass up the side. The green area, totally stable. The red, unstable. But look where we are. All our measurements plant us right in that little yellow slice in between, the metastable region.
And again, this isn't just guesswork. This is based on incredibly precise measurements from our most powerful particle accelerators. You can kind of think of it like a cosmic recipe, The top quark's heavy mass is trying to destabilize everything, while the Higgs's mass is trying to prop it all up. And the values we've measured create this very specific balance that pins our reality right in that metastable state, that little dip on the side of the hill. We're stable for now, but yeah, not necessarily forever.
So, what would actually happen if our universe finally took that plunge? What does it even look like when a false vacuum collapses?
Well, it could start literally anywhere, thanks to this bizarre quantum trick called tunneling. It's where a particle can kind of just appear on the other side of a barrier it shouldn't be able to cross. A tiny bubble of that true vacuum could just pop into existence. And from there, this bubble would expand outwards at nearly the speed of light. Anything it touches would be instantly rewritten with completely new laws of physics. We're talking atoms dissolving, stars vanishing. It would be the ultimate cosmic delete button.
And get this. The physicists who first figured this out, Sidney Coleman and Frank DeLucia, they described what happens next in pretty chilling terms. Inside that expanding bubble, the new physics would be so totally alien that space-time itself would just collapse in microseconds. You wouldn't see it coming. There'd be zero warning.
Okay, that is absolutely terrifying. Which, of course, brings up a pretty big question. If this is possible, why are we still here? Why didn't it happen already? Especially during the most violent, chaotic time in cosmic history, the Big Bang.
I mean, the early universe was this churning, high-energy inferno. It was the absolute perfect environment to give our little cosmic ball that nudge out of its divot. So, what saved us? What stopped the whole thing from collapsing before it even got started?
Well, it turns out there was this epic cosmic tug-of-war going on. On one side, you had the Higgs field, trying its best to pull the universe down into that true vacuum state. But on the other side, fighting against it was a pretty surprising hero: gravity.
See, in the very first fraction of a second after the Big Bang, the universe went through this insane burst of expansion. We call it inflation. And this expansion was so fast, so violent, that it actually curved space-time itself, creating this incredibly powerful stabilizing force. It basically acted like a cosmic safety rail, holding the Higgs field in place and stopping it from tipping over the edge. So, in this beautiful ironic twist, the very violence of the universe's birth is what saved it from destroying itself.
All right, so gravity was our savior in the beginning. But what about now? What's the final verdict on the fate of our universe today? Things are a lot calmer now, right? Inflation is long over. So is that doomsday bubble still something we need to worry about? Is our time finally running out?
The short answer, nope. Physicists have actually run the numbers on this. They've calculated the odds of one of these bubbles just spontaneously popping into existence today, and the predicted lifetime of our false vacuum state is, well, it's more than 10 to the power of 65 years. And just to put that number into perspective, the entire universe is only about 13.8 billion years old. The number we're talking about for our vacuum's lifetime is a 1 with 65 zeros after it. It's so ridiculously, astronomically unlikely to happen that the sun will have burned out and all the stars in the sky will have faded to black long, long before it's even a remote possibility. So yeah, our universe might be temporary in theory, but for you, me, and everyone else, it's forever.
So let's recap the big takeaways here. We live in this really special metastable universe that, yeah, could theoretically collapse, but the chances of that happening are basically zero. And the only reason we're even here to talk about it is because in those first critical moments of creation, good old gravity gave us just enough of a boost to hold everything together.
When you think about it, the story of the Higgs vacuum shows us we're living on a cosmic knife's edge, the result of this incredibly delicate, almost improbable balance of forces. And it really makes you wonder, doesn't it? As we keep peeling back the layers of reality, what other astonishing, maybe even unsettling truths are just waiting for us to find?